Okay, previously I said, okay, let dy dx equal this, which is homogeneous of degree 3. Now I've added the denominator, but we'll get to that in a minute, okay? This homogeneous of degree 3, we let u equal x over y, so y equals ux, and we do all the transformations and transform the equation into this form, which is not separable. It's supposed to be separable. Well, bonehead here. You know, I wasn't following the recipe in the book because I've been a while since I've done homogeneous equations. My previous text didn't do them, but it's pretty simple. Well, I left something out. Now, the criterion in the book is that m dx plus n dy equals 0 is homogeneous if m and n are both homogeneous of the same degree. Okay? Well, if I put this into the form m dx plus n dy, n is going to be the reciprocal of this, and m is going to be 1. That doesn't work. Well, the thing that I glossed over in my mind here is that, okay, if it's as I said, if it's as it was, then the degree of your n function, or it's going to be homogeneous of degree 3, but your m function, the one that's multiplied by dx, is just going to be 1, and it's not homogeneous of degree 3. And we can fix that just by adding a denominator here of degree 3. So let's just quickly kind of look at what happens to this equation. Okay, let's see, a little board management here. Do a little more of this board over here. Actually, I'm going to go ahead and just point the camera over this way a little more. Okay. Okay, so if we have this, well, you can replace all your x's by alpha x's, all your y's by alpha y's. And this is going to end up homogeneous of degree 0. Okay, meaning that the numerator denominator are homogeneous of equal degrees. Okay. Okay, well, the equation can be rewritten as, let's say, x to the 4th, y to the -1, plus x squared y dx minus quantity xy squared plus y cubed minus 3x squared y dx, just trying to be careful, equals 0. Now, this is homogeneous of degree 3. This is homogeneous of degree 3. Again, equivalent to saying if you rearrange it to dy over dx equals, it's going to be homogeneous of degree 0. In other words, replace x and by alpha x, y by alpha y. You're going to get an x cubed, an alpha cubed up here, an alpha cubed down here, and they'll divide out. You'll have homogeneous of degree 0. Okay. Now that we've done that, we do the same substitution. And the substitution was, just to remind you, because I'm not going to go through the details, u equals x over y, so that dy dx is x du dx plus u. Okay, you can go back to the original video for a longer explanation of that. But that tells us that the equation, which I write like this, is going to be dy dx. Well, that's x du dx plus u is equal to this, but with, where is it? Y equal to ux. So for every y, replace it by ux. So that's going to be, okay, replace y by ux, you're going to get u squared x squared. So you're going to get u squared x cubed. And then you're going to get plus u cubed x cubed. Then you're going to get minus 3u x cubed in the numerator. In the denominator, you're going to get an x to the fourth, and think of this as x to the fourth over y. And you're going to divide by y, which is ux. So you're going to have x cubed over u. And then you're going to have x squared y. And again, we had an x squared y here, but we had three of them. That's going to be ux cubed. Notice what happens. All your x's over here can be factored out of the numerator and factored out of the denominator, and then divided out, and they go away as long as x isn't zero. Often have to worry about that. I'm not going to worry about it right now. Do we get x du dx plus u equals u cubed plus u squared minus 3u over reciprocal of u plus u. Now we can simplify things down here, put all this over common denominator and so forth, or equivalently, multiply both numerator and denominator by u. And we get u to the fourth plus u cubed minus 3u squared over 1 plus u squared. Now we can subtract u from both sides. And then we can divide both sides by x. So the du dx equals write it like this, 1 over x times the quantity, u to the fourth plus u cubed minus 3u squared over 1 plus u squared minus u. And then if we put this over the common denominator, 1 plus u squared, we have du dx. And check my algebra here. I'm fairly alert right now, so maybe I'll get it right. If I multiply both numerator and denominator here by 1 plus u squared, I get u plus u cubed over 1 plus u squared. So I'm going to get u to the fourth plus u cubed minus 3u squared minus u minus u cubed over 1 plus u squared. Looking kind of ugly here, but take what we get. So that du, well, I'm going to write it out this way. I'm going to write 1 plus u squared, multiply both sides by the reciprocal of this thing. Okay, and then what do I have here? Something's wrong here. I should just have a u. U squared, okay, a u squared and a minus 3u. I've got a square on this u here. Shouldn't be there. Okay, so now I've got a 3u minus u, that's a negative 4u. And I've got a u cubed minus u cubed, which eliminates the u's. So I've got u to the fourth down here, minus 4u. Now, integrating this, we're not going to worry about it right now. Anyhow, this is dx over x. And you see that the equation has been transformed to a separable equation. We separated everything. And now we can integrate. We're going to get a natural log of x here. Not sure what you're going to get there. Factor u out of this and use partial fractions and see what you've got. But I think it might be a little tricky to integrate. I'm not going to work through the details. Okay, so that fixes the bonehead thing I did with my introduction to homogeneous equations. I got hung up on the step that wasn't really necessary, where I justified why that one polynomial was homogeneous of degree 3. And then I wrote down something. And you saw what happened. There it is. That repairs that one.